In this video, we're going to talk about something called the AC generator, but this is also one of the most common applications of changing theta, right? And so what we have is a uniform magnetic field created by these two magnets over here, and you have a metal coil that is going to start spinning around, and in this case, you see I have drawn that it's going to be spinning around in a clockwise manner. Now, here's the thing, right? Let's come down here. When your coil is 90 degrees to the field, we know that your flux linkage is going to be a maximum, right? But when your coil becomes like this, right, parallel to the field, your flux linkage is going to be 0. And so what we are actually looking at over here, right, if I plot the flux linkage with theta, right, let's assume that the coil starts off in this position, then it's actually going to look like a cosine curve. Right, this of course being 360 degrees, 180 degrees over here, 90 to 70. What I'm going to do, I'm going to use a little trick. If this coil rotates at a constant angular velocity, then the angle that it makes with the field is going to be expressed as omega t. Right? Angular displacement is angular speed times time, if the angular speed is constant. And so, what I can express phi equals to NBA cosine theta can be written as NBA cosine omega t. And so, if I try to calculate the EMF induced in this rotating coil, remember this is negative d phi dt, and if we do some simple differentiation, like cosine will become negative sign, so if you negative that, it becomes positive sign, so but the omega will come out, so this becomes omega NBA sine omega t. And so when we do a little comparison with the two graphs, oops, wrong thing, right? Let's change this to t here. Right, of course, this would be the period now. You'll see that your EMF will then be a sine curve, okay, with an amplitude of omega NBA, okay, and so that, of course, is also your peak EMF. Very interesting stuff. So notice that the EMF that you induce in this generator is going to be an alternating one, okay, which of course links us very nicely to the chapter of alternating currents.